So the second type of calculation that we're going to look at today is for home loans or any other type of loan. So for a home loan calculation for annuities, we start with a large amount of money that's been borrowed, and then each contribution is actually reducing that amount that's left to pay back. So we're going to be subtracting the contributions from the amount that's there to charge interest on. So I'll show you this with an example. Our example says that Thea takes out a home loan of $360,000. Her interest rate is 3.5% per annum. How much does she owe after 5 years if she makes repayments of $20,000 per year? Now, this is only contributing money once a year, so we're only going to compound the interest once a year. This is not a particularly realistic example because in real life, people tend to pay their home loans down fortnightly or monthly. But it will show you what the calculations need to look like. So, just like last time, we can set it out either in a table or using the formula. So we'll start with the table. This is over 5 years again, so we'll have 5 rows. The contribution is the $20,000 that she's paying off each year. So that will be the same for every line of working. And then the first amount that we start with is the original $360,000 that's been borrowed. So the final amount at the end of the first year will be the $360,000 times by the interest rate as a decimal added to 1. So we can either write it in brackets as 1 plus 0.035, and that would be to the power of 1, or just like I did last time, I'm going to add those together and just make it 1.035, so there's less writing. And then when we take the contribution into account, we're actually subtracting it because this is a debt. So she's paying off the debt is getting smaller, so we're subtracting. So this means that at the end of the first year, we end up with $352,600. Then, just like last time, this now becomes our principal for the second year. And we are being charged 3.5% interest on this, so we'll times it by 1.035. And then again, she's paying $20,000 off that loan, so we're going to subtract it. And we'll get $344,941. And then the rest of the example will continue in the same way. It's exactly the same formula, so I won't fill that out now, but it will be completed on your notes if you want to look at the PDF. Using the formula, very similar to what we did with the superannuation account. For the first year, so the value at the end of year 1, it's going to be equal to the value at the very start times by 1 plus the interest rate is 0.035, but again, I'm just going to write that as 1.035. And then we're going to take away $20,000. So we already know that that's going to be $352,600. Then the value at the end of the second year is going to use that value times by 1.035, take away $20,000, and we get 344,941. So then at this point, you can type this in your calculator, use 360,000 for V0 because that's what we start with, and then once you've hit enter, just go back and change this to answer, the button next to equals on your calculator, and then you can just hit equals 4 more times to get your 5 remaining rows for this calculation. So V5 is the final answer that we're looking for, Because the pattern just continues on like this, I'll let you guys either fill that out or go to the PDF notes to see the rest of that example.